have all dreamed for decades that there would be a new space race, not one dependent on massive budgets and national pride, but one dedicated to the exploration of space and the advancement of humanity into the solar system. We have seen the benefits of competitive technology revolutionize the computer industry, the internet, and personal communications. But the concepts of innovative research, prototyping, and development were out of reach for most in the space industry. Until now. Hello and welcome to the Terran Space Academy, where we help prepare you for a bright future in the space industry. Please don't forget to like and subscribe, and support us on Patreon or the Academy store if you can. There are links in the description. New technologies have put advanced construction methods into many hands, and we are finally beginning to see true competition in the space industry. SpaceX was the first new tech company to apply the principles of Silicon Valley to the space industry. And they have had great success, developing the most dependable, partially reusable rocket system the world has ever seen. No one had believed that the first stage of a medium-lift orbital rocket could come back and land, until SpaceX proved it could. The Falcon 9 rocket system is an amazing example of innovation and creativity. The Falcon 9 is a two-stage rocket burning RP-1 through 9 Merlin rocket engines. The Merlin engine itself is amazing. It has the highest thrust-to-weight ratio of any engine flown to space so far. 9 of them get the Falcon 9 first stage up to 88 kilometers, almost the edge of space. Then the engines shut off. This is called main engine cutoff or MECO. The rocket is traveling at over 7,200 meters per second at this point. Without constant thrust, the rocket starts slowing down due to residual air drag and gravity. Now the two stages separate. The first stage continues to decelerate, while the second stage gets a safe distance away. And firing its one Merlin vacuum engine, flies on into orbit. On its way, the second stage releases the fairings. Fairings are protective shells around the top of a rocket. These are used to protect the payload from aerodynamic stress and help reduce aerodynamic drag. The first stage then goes back to land, either at the launch point or onto a barge in the ocean. The first stage can then be reused. The SpaceX Falcon 9 fairings have now been equipped with parachutes, and they are recovered from the ocean and refurbished. The second stage cannot be recovered. This is because the second stage goes much faster than the first stage. On re-entry, this velocity becomes thermal energy, which would burn up the SpaceX second stage if it tried to re-enter the atmosphere. The first stage, however, going slower, can come back and land. This is the most reusable rocket system that has ever existed. Until now. Now a very innovative rocket company, called Rocket Lab, led by its own genius entrepreneur, Peter Beck, has looked at everything SpaceX has done and loudly proclaimed, "We can do better." Rocket Lab started in New Zealand, where Peter Beck had grown up. Mr. Beck and his company had developed the Electron rocket. The Electron rocket had the first all 3D printed rocket engine, a technology that we have considered critical to success in space. This engine is called Rutherford and burns RP-1. Rocket Lab also pioneered the use of electric propellant pumps for small rocket engines. This was another innovation, and several companies have copied the concept. You can review the technology on this lesson. The Electron rocket, like the Falcon 9, is also a two-stage rocket that uses RP-1 for fuel on both the first and second stages. The main difference is that the Electron is a lot smaller and is made of mostly carbon fiber with some aluminum, while the Falcon 9 is made from mostly aluminum with some carbon fiber. Rocket Lab is staying busy and has developed an innovative kick stage. This is called the Photon and has its own propulsion system, small for orbital changes and much larger for interplanetary flights. The Electron rocket can get 300 kilograms to low Earth orbit. There are a lot of small payloads this size that need a dedicated launch. But the Falcon 9 can get 8 tons to low Earth orbit, reusing the first stage booster. And it could get over 23 tons if it discarded the booster. Rocket Lab hopes to start recovering the Electron first stage also, They plan to do this by deploying a parachute and catching it with a helicopter in midair. This works fine for a small carbon fiber rocket, but would not work for something the size of a Falcon 9 first stage. SpaceX has an incredible advantage reusing their first stage boosters. These can be flown up to 10 times. This is 9 first stage boosters SpaceX doesn't have to build and throw away, and 90 Merlin engines also. No other company has anything reusable. But if you want to compete with SpaceX, you will have to step up your game. 300 kilograms won't compete with 8,000. And Rocket Lab has just done that. Rocket Lab had previously announced its goal of building a bigger rocket. This would be called the Neutron. We don't know a lot about it, but Peter Beck literally ate his hat in front of a large payload fairing. Peter had said at one time he would not build a larger rocket, or try to reuse any parts of any of his rockets. He has changed his mind on both these concepts. Peter decided to maximize Rocket Lab's strength in carbon fiber rocket production. Rocket Lab has revolutionized the concept of carbon fiber propellant tanks. We saw these being developed for the X-33 single-stage-to-orbit concept vehicle, but at that time, they couldn't get it to work for hydrogen. The Neutron rocket will use carbon fiber in its construction. This will make it very lightweight. It will be a 2-stage methane-fueled rocket. The first stage will launch the system into orbit using 7 Archimedes rocket engines. The Archimedes engine will be powered by methane and liquid oxygen through a gas generator cycle. Remember that this means a preburner will burn some fuel and oxygen, and use the energy produced to power the turbopump system, which then pumps more propellant into the combustion chamber. This is how many rocket engines work, including the Merlin by SpaceX. The methane over RP1 will allow the Archimedes to burn cleaner than the Merlin. This will obviate the need to refurbish the engines between flights. Each engine will produce up to 1 meganewton of thrust. Divide by about 10 to get the 100 tons that Elon likes to use. These engines will have a specific impulse of at least 320 seconds. We immediately recognize that if we have the thrust and specific impulse, we can calculate the ejection velocity and mass propellant flow. 320 seconds of specific impulse gives us an ejection velocity of 3,138 meters per second. Now, if we use this equation with the known thrust and ejection velocity, we get a mass propellant flow of about 319 kilograms per second per engine. 7 of these will be on the bottom of the rocket. That gives us a total propellant burn at maximum thrust of 2.23 tons per second. The launch mass of the rocket, as given by Mr. Beck, is 480,000 kilograms. We don't know what mass payload that includes, so we will assume 8,000. With a mass of 480,000 kilograms, we have a weight of 4,707,360 newtons. With each engine producing 1 million newtons of thrust, and 7 engines, we get a total thrust of 7 million newtons. That will give us a thrust-to-weight ratio on launch of about 1.5, a respectable number. The rocket will burn through the propellant in the first stage, then do something really creative. It will not have fairings like every other rocket. It will have this. This system protects the second stage but is not discarded. No need to chase fairings around the ocean. This also allows the second stage to be very lightweight. This can dramatically increase the performance of the second stage. The second stage fires and goes into orbit. It will be able to get 8 tons into low Earth orbit while reusing the first stage. This is about equal to the Falcon 9. And the Neutron can manage 15 tons if the first stage is sacrificed. This is not as much as the Falcon 9 expendable, but only 20% of launches were over 10,000 kilograms. The other 80% of the launch market will be smaller satellites. The first stage will come back and land. With the mass savings from using carbon fiber, the landing legs can be integrated into the construction. Rocket Lab had considered using stainless steel and aluminum, but decided that their custom-made carbon composite would be lighter, stronger, and better. This was possible because they have an automated fiber placement technology that they use to make their rockets. The rocket is also made with a slight taper all the way up. This reduces shock waves on launch and re-entry. When we compare the Rocket Lab Neutron system with the SpaceX Falcon 9 system, we will see that if this rocket flies, it will prove that just because one entrepreneurial genius has a great idea Doesn't mean another one can't come along and beat it. This doesn't mean that the SpaceX Falcon 9 won't be able to make a profit. It just means the medium lift launch market is about to get very competitive. And that's good news for everyone who loves space. Something to think about. Let us know what you think, and stay safe at Astra Pro Terra.